In this lesson, we're going to focus on something called conditional probability. Perhaps you've seen something like this: P of A with a bar next to it and then a B. What does this mean? This represents the probability that event A will occur given that event B has already occurred. So let's say we have a six-sided die with a sample space of the numbers 1 all the way to 6. And let's say that event A is any time we get an even number by rolling, or let's say an odd number when we roll the die. So 1, 3, and 5. And event B, let's say that corresponds to the numbers 3, 4, and 5. So what is the probability that event A will occur given that B has already occurred? Before we get into the formula, let's talk about a quick and simple way of getting the answer. Ask yourself this question: how much of A is in B? The elements of A that is in B is 3 and 5. So there's 2 elements of A that is in the 3 elements of B. So 2/3 of B is basically from A. So that's the probability of event A occurring given that event B has already occurred is 2/3. That's a quick and simple way to do conditional probability. But now there's a formula that you need to know. To calculate this conditional probability, it's the probability of event A and event B occurring divided by the probability that event B will occur. So what is the probability of getting event B? B has 3 outcomes that lead to it out of a total of 6 outcomes in a sample space. So when you roll a 6-sided die, there's 6 numbers you can get, and B is half of those numbers. So the probability that event B will occur is 3 out of 6. Now, what about the probability of events A and B occurring? Well, let's write the sample space for A and B. So this is the intersection of A and B. And we know that the numbers 3 and 5 corresponds to A and B. So event A and B will occur if we get 2 numbers out of the 6 potential numbers that we could get. So the probability of A and B occurring is 2/6. Now to simplify this complex fraction, let's multiply the top and bottom by 6 so that the numbers 6 will cancel. And so we're left with 2/3, which is the same as what we see here. So that's a simple way in which you can calculate the conditional probability of an event occurring. But now let's look at some more example problems. There are 500 students in a certain school. 150 students are enrolled in an algebra course, and 80 students are enrolled in a chemistry course. There are 30 students who are taking both algebra and chemistry. If a student is chosen at random, what is the probability that the student is taking algebra? Before we begin, let's draw a Venn diagram. So we're going to draw 2 circles with the circles intersecting each other. Let's put A for algebra and C for chemistry. So there's 150 students taking algebra, and there's 80 students taking chemistry. There's 30 taking both. And in this school, there's a total of 500 students. So what is the probability that the student is taking algebra? So there's 150 students taking algebra out of a total of 500 students. So this becomes 15 over 50. 15 is 5 times 3, 50 is 5 times 10. And so the probability of selecting an algebra student is 3 over 10, which is 0.3 or 30%. Now, what about part B? What is the probability that the student is taking chemistry given that the student is also taking algebra? So this is a conditional probability problem. So we're going to find the probability of getting C given that the student is taking algebra, or given A. So how much of C is in A? Think of it that way. We have 30 of C that is in A, so it's going to be 30 out of 150. Now, for those of you who prefer to use the formula, this is going to be the probability of getting C and A divided by the probability of getting A. So the probability of getting C and A, the probability that a student is taking algebra and chemistry, is 30 out of a total of 500 students. The probability of a student taking algebra, that is the probability of A, is 150 out of 500, which we calculated earlier. And so multiplying the top and the bottom by 500, you could see we're going to get the same answer. It's going to be 30 over 150. So let's simplify 30 over 150. 30 is 30 times 1. 150 is 30 times 5. So the probability is going to be 1 over 5, which is 1 divided by 5 is 0.2. So there's a 20% chance of selecting a student who is taking chemistry given that they're taking algebra. Now let's talk about what this means. Out of all of the 150 algebra students in this school, 20% of them is taking chemistry. 20% of 150 is 30. Now let's move on to the last part of this problem, part C. What is the probability that the student is taking algebra given that the student is also taking chemistry? So going back to part B, we said the probability of getting C given A was 1 over 5. Now, in this problem, we're looking for something different. We're looking for the probability of A given C, and these are not the same. So what is the probability of selecting a student who is taking algebra given that that student is taking chemistry as well? So how much of A is in C? Notice that we have 30 of A that is in basically 80 of C. So this is going to be 30 over 80, which we can reduce that to 3 over 8. So out of the 80 students who are taking chemistry, 30 of them is taking algebra. So the probability of selecting a student that is taking algebra, given that they're taking chemistry, is 3 out of 8. And so that's a simple way in which you can do conditional probability calculations. Let's move on to the next question. There are 200 birds in a zoo. 70 birds are male with brown eyes, and 100 birds are female with brown eyes. 20 of the birds are male with blue eyes, and 10 birds are female with blue eyes. Construct a contingency table. So let's begin by doing that first. So on the left, we're going to have the gender. So it's either male or female. And at the top, we're going to put the color of the eyes, either blue eyes or brown eyes. Let me pick a different color for this. And at the sides, we're going to put the totals. So 70 birds are male with brown eyes. So let's put a 70 here. 100 birds are female with brown eyes. 20 birds are male with blue eyes. 10 birds are female with blue eyes. So what's the total number of males? 70 plus 20 is 90. Now the total number of female birds is going to be 100 plus 10, which is 110. So adding these two will give us a total of 200 birds in this zoo. Now let's add these numbers. So the total number of birds with brown eyes is 170. The total number of birds with blue eyes is going to be 30. And we can see that 170 plus 30 is 200. So now that we've filled out the contingency table, let's answer some questions. If a bird is selected at random, what is the probability that the bird is a female? So let's start with that. So what's the probability of getting F? So there's 110 birds that are female out of a total of 200 birds in the zoo. So the probability is going to be 110 over 200. If we divide both numbers by 10 by getting rid of a 0, the probability is 11 over 20, which is 0.55 or a 55% chance of selecting a female bird. Now, what about selecting a bird that is a male with brown eyes? So this is not a conditional probability question. We're looking for a bird with two characteristics. It has to be a male and it has to have brown eyes. So there's 70 birds that are both male and with brown eyes out of a total of 200 birds. So the probability is going to be 7 out of 20, which is 0.35, which corresponds to a 35% chance of selecting such a bird. Now let's move on to part C. So what is the probability that the bird is a female given that it has brown eyes? So now we're dealing with a conditional probability question. So what is the probability that we're going to get F given BR? So to do it the easy way, think about this question. How much of F is in BR? So out of all the birds with brown eyes, how much is female? So there's 170 birds with brown eyes. 100 of those birds are female. So it's going to be 100 out of 170, which reduces to 10 over 17. Now, if we divide 10 by 17, that's going to be 0.588. So let's talk about what this means. That means there's a 58.8% chance of selecting a bird that is a female, given that the bird has brown eyes. So out of all of the 170 birds with brown eyes, 58.8% of those birds are female. So that's what that means. Now let's move on to part D. What is the probability that the bird is a male given that it has blue eyes? So what's the probability of M given BL? So how much of M is in BL? There's 20 of M and 30 of BL. So there's a total of 30 birds with blue eyes, 20 of which are male. So the probability of selecting a male bird, given that it has blue eyes, is 2 over 3. So So as you can see, it's really not that difficult when calculating conditional probability if you understand the principles behind it. Now, before we answer the last question, I just want to clear away a few things because this page is getting crowded now. So the last part, what is the probability that the bird is a creature with blue eyes given that it's a female? So what's the probability of BL given F? So how much of BL is in F? So there is 110 female birds, 10 of which contain blue eyes. So the probability is going to be 1 over 11. There's, out of all the 110 female birds, 10 of those have blue eyes. And so this is it. That's all you got to do. It's 10 over 110, which reduces to 1 over 11. And let's turn that into a decimal value. So that's approximately 0.091 if you round it. So there's a 9.1% chance of selecting a bird with blue eyes given that it's a female.